All right, today we are going to be talking about the law of conservation of mass. In reality, we've been talking about the law of conservation of mass and the law of conservation of matter much longer than just starting today because we've been balancing chemical equations. And the whole reason that we balance chemical equations is so that both sides of the reaction are equal. The same is true in math. So now we're going to mathematically look at the law of conservation of mass. So the equations here should be balanced. There are a few that are incorrect, but they should be balanced. What we need to see is that the left are the reactants and the right are the products. The products and the reactants must be equal. So you can look at this arrow as an equal sign. Okay, so just like in math, if you had a variable, what you would do is you would add together the side that you know and then subtract what you have on the right side with your variable from your total. So if I had my calculator, which you need your calculator out, I would add 60 plus 64 to get a total of 124 grams on the left, on my reactant side, equals 88 plus blank. When I do my subtraction, I subtract 88 from both sides. And what I get is that 124 minus 88 is 36. So 36 would be what I add to that blank over there. And the way I did that is I did 124 minus 88, and I got 36. So I saw that if I wanted my right-hand side to equal my left, I needed to make sure that whatever went in that variable added to 88 to make the same total as on the left-hand side. So let's look at this one. We basically got 40 plus x equals 78 plus 64. So I add 78 plus 64 and I get 142. So if I do that, I get 40 plus x equals 142. So when I subtract 40 from both sides, I get 142 minus 40 equals 102. And that's what goes in our blank right here. And the way that you check yourself is you go back and you say 102 plus 40 equals 142. All right, so if we look down just a little further, we're going to see very similar problems. 250. One way to make it neater on here is to go ahead and total these up first. 256 plus 256. We have 512 equals blank grams. Both sides have to be equal. That means that I just put 512 here. All right, in the next question, you have hydrogen peroxide breaking down into oxygen gas and water. And I have 100 equals blank plus 68. So when I subtract 68 from both sides, what I get is 32. So 32 goes in my blank. All right, here I have x, basically, plus 38 equals 115. So we subtract 38 from both sides, and we get x equals 77. All right, so we have 22 plus x, and I know you can't see that, sorry. 22 plus, I can just put blank or an x, blank equals 45 plus 74 is 119. So when I subtract 22 from both sides, I get 97. And you'll notice both sides total to the same exact number. Here, I have blank plus 32 equals 146. So I can subtract 32. Subtract 32. Since I was adding it to both sides, now I'm subtracting it. And I get 114. So 114 goes right here, plus 32 is 146. Okay, this equation is not right, but if we have 115 of some sort of a compound equals blank plus 73, we subtract 73, and you get 42 grams. All right, last one. 35 plus 50 is 85 equals 45 plus how many grams? Subtract 45 and you get 40. All right, now I want you, this was page 23 in your packet. I want you to turn to page 24. Okay, at the top it says a student mixed 125 grams of sugar, 250 grams of water, and 5 grams of flavoring. What is the final mass? The final mass is 125 plus 250 plus 5, which is 380. Jim Bob and Sally Mae were each given a ball of clay the same weight. I already see they're the same mass, so no matter how you roll it, they're going to be the same mass. Figures would be equal. Adrian has 10 grams of water in a pan and then he freezes it. The ice cubes are larger than the actual water, but 10 grams of water is 10 grams of water. 13. 15 grams of vinegar is added to 100 grams of milk. What is the mass? 115. It literally says added, so 15 plus 100. 5 grams of salt is dissolved in 100 milliliters of water to form a salt water solution. The solution is heated and the water is boiled away. How much salt would you expect to have left? I would expect to have as much as I started with. B. 46 grams of sodium reacts with 70 grams of chlorine. So if I add those together, I get 116. The final product forms sodium chloride. How many grams was produced? 116. 108 grams of aluminum combines with oxygen. The final product is 204 grams. How many grams of oxygen combined with aluminum? So we've got this much aluminum, and this is our final product. So in order to find out how much we started with, I take my final product, 204, I subtract 108, and I get 96. All right, 98 grams of iron combines with 25 grams of oxygen. What's the final product of iron oxide? I take 98 plus 26. 8 and 6 is 14, 9, 10, 11, 12. 124 grams. All right, now I want you to flip here and look at page 25. This is page 25. You are looking to see if you can figure out how much is needed, how much was used to make the entire equation balanced. So I start with a 15.9 gram sample of sodium carbonate. It's added to a solution of acetic acid weighing 20 grams. So I already see 15.9 plus 20. The two substances react, releasing carbon dioxide gas into the atmosphere. After the reaction, the contents of the vessel weighed 29.3. So how much carbon dioxide was released? So this total is 35.9. So the total in the reaction was 35.9. Now it says after the reaction, there was 29.3. So how much carbon dioxide was produced? Well, we subtract just like we did in the last one. 35.9 minus 29.3 equals 6.6 grams. So I want you to do 2, 3, and 4 and see if you can figure out the answers on your own.